Hi, my name is Mandis Momberg and I'm a Principal Solutions Architect with AWS. And I'm joined by Carmen Puccio, who's also a Principal Solutions Architect with AWS. And today we're going to talk about how to modernize your application sets. And we're going to do that specifically by looking at a couple of technology stacks that our customers are very frequently using. Specifically today, the .NET application stack. And Carmen would point out that it's the modernized version of the .NET Core library. So Carmen, tell us a little bit more about what you did in the sample application and why we chose this as a specific application.
Yeah, so you might remember from the last video series, we took the Java Pet Store application, which we essentially walked the user through how to take that application, containerize it, and deploy it to something like AWS Fargate. We're seeing more and more of our customers actually want to know how to take a traditional Microsoft application that they're familiar with, maybe something like an MVC application, and move it to .NET Core. And then subsequently taking that application and deploying it inside of something like AWS Fargate or something like EKS, and getting that application into a little bit more of a modernized workflow. So instead of taking the Java Pet Store application, we built something net new, and being AWS, we love the concept of unicorns, so we built what we call the Unicorn Store. So it's a traditional MVC application themed around buying and purchasing unicorns, but we're going to walk the user through essentially how you take that application, do your local development, and specifically walk through how to do things like handling secrets, which is very important as you go from environment to environment. A lot of times when you talk about taking an application and moving it from your development environment into your QA environment and then subsequently to production, the one thing that you don't want to do is store any sensitive information inside of that application. So we built a workshop that we have up on our GitHub pages now under AWS samples, which shows you how to do just that.
So it's interesting you've mentioned the term MVC a couple of times in this. What is MVC?
So think of it as the model view controller. It's a traditional way of essentially building a web application, right? And a lot of people are familiar with things like if you're inside of the Microsoft stack, you might be familiar with what we call the music store, right? This is just a simple play on that. And we're going to show you how you essentially build your application and what's changed inside of .NET Core in terms of handling sensitive information like secret.
So MVC is usually considered a traditional application design. When you think about modern application design, you think about 12-factor applications, you think about RESTful services. How do you go from this traditional application design into a more modern design? Because when you think about a modern design, you think 12-factor application, you think RESTful services, yet that doesn't seem to really show in what you just explained.
Yeah, so the first thing you want to think about is essentially making that application environment agnostic, right? The way that you build it on your development machine and the way you ship it from development to QA to production, it should essentially behave the same, right? And containers are a great vessel for that. So one of the things that we did was we externalized the whole process of secrets, right? So a very common thing to do inside of any application is to have something like a connection string to a database, or to have some sort of secret information about that application that makes it run. Think of like maybe an administrator username and password. We externalized all that. So as part of this workshop and part of what we're going to demo here today, we're going to show you how to do that inside of .NET. So as the application spins up, how do we inject those secrets and how do we access them inside of .NET Core so that way, regardless of what environment you're building in, it'll behave exactly the same.
Right, so that immutability factor, that basically when you run it, doesn't matter where you run it, it runs the same way that you would expect it to run. And then decoupling things like secrets and storage and configurations away from the application to allow you to start modernizing and breaking that application down a bit and introducing things like RESTful APIs and 12-factor application design systems. So it's again like the application we did with Java, but this time just with .NET. You can take a monolithic application design and then slowly port and make it more modern, more secure, and more easily deployable across multiple environments.
Yeah, the thing to really emphasize here is by taking this application, this traditional application, and putting it into a container, it's a great vessel for you to essentially think about how you can become more agile in your practices, right? It becomes very easy to test and iterate and ship it out. So again, in a little bit later in the subsequent videos, we'll talk about how you can deploy this application into a pipeline, but in this context, we're really just going to talk about the secrets management.
So the ideal situation would be to run this application in multiple environments. That's why we like things like containers. But you had to make some changes in the way that it got credentials and connection strings securely. Would I need to custom write code and have multiple versions of my application for each environment that I run in?
No, they make it super simple inside of .NET Core to essentially handle this. So there's the concept of essentially the configuration API. So if you take a look at the application, Most people who are familiar with .NET development, you know that the entry point of the program is program.cs. Essentially, this is your starting point. And what you'll see here, you'll see there's a method called create default builder. And this is essentially where the order of operations come through. So if you think about it, whether it be a flat file or environment variables or a command line argument, this is where you're going to define essentially how you want the application to start up and then where you want to pull this information from. And then from there, you have the concept of the startup.cs class. And you'll see here we're driving the configuration in. And then at the same time, too, it's looking for our configuration. So regardless of the environment, as long as the configuration is passed in along one of the things that we're looking for as part of the default builder class, it'll behave essentially the same regardless of the environment.
So in the application, you're essentially defining a propagation list of where to go find the credentials, and whichever one it picks up first, that one will be used inside of the environment.
It's actually last one wins, which is interesting. So the order of operations is files. So if you think about the application settings that I showed before, the user secrets, the environment variables, or the command line arguments, whatever one comes last is essentially the winner. And the cool thing about that is environment variables are a very common way of launching a container. And when we launch the container inside of something like AWS Fargate, we're going to use environment variables, but secure ones from AWS Secrets Manager to start the application.
Okay, so the application don't necessarily care where this information comes from as long as it sits inside of that chain.
Correct.
And that allows us some flexibility in all of our different environments in how we pass that information to the container.
Correct.
Okay, well, if you could go ahead and show us a little bit about that and how you were able to do that.
So the first thing I want to talk about is the concept of .NET Core Secret Manager. It's essentially a tool that you can use during your local development building or your local development environment that allows you to store sensitive information, but it's externalized from the project itself. Because the one thing you never want to do is take that information or that sensitive information like database username and passwords or any sensitive information and put it in source control, right? You want it to essentially be something that is unique per environment, but at the same time too, when you're working inside of your dev environment, you don't want to hard code those values into anything that could potentially be checked in. So .NET Core has this concept of Secret Manager, which is a tool that allows you to put this information local to your machine. It is not to be confused with AWS Secrets Manager, which we're going to actually use as part of this build process as well to show you how the two tools can work together. So the first thing I want to point out is we have open sourced this solution, right? So if you go to the AWS samples GitHub repo and you take a look at the modernization unicorn store, you can actually look at all of this code and you can follow along. We built a workshop around it and we've run it at some of our conferences and it's been very well received. But the first thing that you want to do is, again, you want to think about how you can actually build this local to your dev environment. The instructions will walk you through how you could do it in something like Cloud9. I'm going to do it locally to my Mac inside of Visual Studio Code.
Yeah, and again, because it's mainly in containers, you can run it in any environment, whether it's in the cloud, on your local development environment, wherever.
Yeah. So the very first thing I want to point out here is if you look at essentially my project layout, it is just like a traditional .NET application, right? You have a concept though of essentially application settings, right? And the application settings, you'll notice they're called out by development, production, so on and so forth. Essentially, this is the hierarchy that we're going to work around. But the key thing to call out here is if you look at the application settings file for development, for instance, the connection string is inside of here, but you'll notice there is no username and password that's being specified here. And the same thing subsequently with our default admin username and password that we need for our application to run. This is what we're going to externalize. So if I show you how the .NET User Secrets tool works, essentially what happens is you're storing that locally on your machine outside of the project. All right, so the first thing you want to do is you want to actually take a look and see the secret itself. They make it super simple for you inside of .NET Core. If you just run this command, you'll see essentially here what we have is our connection string to our database, or the information that's unique about our database. So you'll see essentially the username, the password, the port, and the DB instance identifier. You're going to use this to construct the connection string as you move from environment to environment. So here I'm working in dev. As I move inside of production, I'm not going to have access to the .NET Secrets Manager tool. What I'm going to use is something like AWS Secrets Manager and inject that in as the container starts up. So you might be asking yourself essentially, okay, so I have this information, it's not stored inside of this application settings file, how do I bring it in? Inside of .NET Core, we have the concept of essentially the startup constructor, the startup class. And what you'll see here is you're driving the configuration in. And once you've actually brought the configuration in, and the way it works is essentially, it's like, think of it as like a hierarchy, right? So whether it be something like environment variables, or you're reading from a flat file on disk, or it's command line arguments, essentially it's the last one that is essentially defined wins. And in our case right now, we're working inside of dev, and the only thing that we're specifying is the .NET secret that's local to our machine. But once we have that information, it's as simple as accessing it through a key value, and then you can see here that we're actually building the SQL connection string for the application as it fires up.
Right. So instead of hard coding this information into your configuration file, or instead of using the .NET secret store, which is also pretty insecure locally and you can share it across multiple environments, you're actually using a managed service from AWS called the AWS Secrets Manager.
Correct.
And you're just pulling that through an automated configuration in your application. So when the application starts at runtime, it reaches out to SSM, pulls in the information and the parameters, and then inject that into your application.
Yeah, the really cool thing about it is inside of something like AWS Fargate, we made it super simple for users to interact with AWS Secrets Manager. And essentially, as you build your task definition file, which I can show you in a second, you have the ability to define, these are the secrets that I want to pull, and they are loaded in as a secure environment variable. And essentially, your task has a permission at the IAM level that allows you to specify which secrets that you can actually talk to. So you think about it, you can actually get really fine-grained controls around how that task runs and what it's interacting with and what secrets it's pulling as it starts up.
So immutability is a large topic that we constantly talk about in containers, and that's what makes containers very valuable to most of our customers. So how does it work when you use a managed service like AWS Secrets Manager as opposed to something like the built-in .NET secret storage and those type of things? Like, how does that affect your application design decisions?
Yeah, so the important thing to remember is the application should start up the same no matter what. And they make it super simple inside of .NET. Essentially, the last one that you define wins, right? So whether it be essentially a file on disk, which is not good practice. You want to think about essentially not storing that inside the Docker image itself, or injecting it in as an environment variable at runtime, or passing it in as a command line argument. So as your application starts up, it should look for that information, but essentially the way that it starts up should not be different from environment to environment. It should just expect it to be there. So then it's up to you as the operator to define how you want to inject that information in. Again, inside of something like AWS Fargate, we made really tight integration between the way that the container starts up inside of Fargate and the way that you interact with Secrets Manager via the task definition and tightly coupling them together. But at the same time, the secret is injected very securely as a secure environment variable.
So there's a couple of considerations that you need to keep in mind when you build your application, specifically around how the application is run and launched inside of this container to keep it immutable, yet connecting to the services that you want. Why should you choose a managed service like SSM as opposed to a local storage?
I think the biggest thing personally is it's something else that you don't need to manage, right? If you want to think about, least privilege essentially and locking down those assets, there's a lot of sensitive information that could potentially be in there for your application. And you want to think about least privilege. And the fact that AWS Secrets Manager tightly integrates with IAM, and you have the ability to do fine-grained access control policies all the way down to the ARN, that's a unique value add that really gravitates itself as to why you should use that service. You don't want to think about having to build all of that workflow itself. Why not move that heavy lifting off to something that's not naturally very easy to build into your application?
So in this sample application that you built, you essentially took a pretty monolithic .NET application, a traditional design that started with MVC, and you containerized it. Once you containerize it, you kind of started breaking down some of the internals of it, allowing it to also persist storage values and connection strings in a service like AWS SSM, and also did it in such a way that regardless of the environment it runs in, it was able to selectively choose where to go and find that information securely. And then once you've started breaking out those little pieces of information, you can now deploy it into something like AWS Fargate or any of the other container services that we have.
Correct.